Stan Gibilisco here to talk a little bit more about the RF speech clipping process, and in particular the filtering process that is used to prevent splatter. What do I mean by filter? In the first video about radio frequency speech clipping, I made it very clear that you needed to use a brute force filter. What exactly is that filter? Well, let's look at a typical voice signal without any speech clipping, without any speech processing. Single-sideband voice signal. It is an upper sideband or USB signal, not universal serial bus, but upper sideband signal, and you can tell that because in this frequency domain display, the signal energy appears above the suppressed carrier frequency. This is the suppressed carrier frequency. Suppressed carrier meaning that it's the carrier that would be there, except the balanced modulator cancels it out to produce the sidebands. So what do you do here? Well, here you have, normally in order to get one sideband or the other, you need to employ a selective filter with what they call a rectangular response. And I've made a video about that, and I believe it's in this same playlist, Teach Yourself Electricity and Electronics Miscellany. Rectangular response just means that it passes energy within a very well-defined range of frequencies. In this case, from about 300 hertz above the suppressed carrier frequency to 3,000 hertz above the suppressed carrier frequency, and the ideal filter would therefore have a response that looks something like this, so that it passes this upper sideband energy within the acceptable passband range, but not anywhere else. Well, normally that's the way that you get the sideband energy in a single sideband signal. You get rid of the lower sideband by applying a filter to the upper sideband. Contrary-wise, you could just flip this around, turn the device that you're watching this video on around into a mirror, and you'll get the situation for the lower sideband. All of the sideband energy would simply appear on the other side of the carrier. Well, all right, if you employ speech clipping in order to increase the average power of the signal without increasing the peak power, you're going to get, as I mentioned before, that bugaboo called flat topping, which will lead to splatter unless you use another very, very well-defined rectangular response filter. Splatter on a spectrum analyzer would look something like this. And it could continue up to over 100 kilohertz in total bandwidth, up 50 or even more kilohertz either side of the signal, and it sounds like a crackling noise in a radio receiver at frequencies well removed from the voice itself. When you're tuned to the voice itself, it may not sound that much different than a normal clipped signal, but you notice the splatter when you tune away from it, and that is, by the way, illegal. The FCC, Federal Communications Commission, will not like you very much if they find out that you are transmitting a signal with splatter. So to get rid of that splatter, you employ a rectangular response filter like this. Now the trick to doing this is that you need to make sure that that filter response is properly centered on the signal energy. If it's a little too high, because you see, you're not doing this in the audio stages, you're doing it at radio frequencies. This frequency, 0 right here, with respect to the carrier, it might be 3.875 megahertz. And so you would want this energy, which would go from 3.8753 to 3.878 megahertz. You would want that filter to have a response right in that zone. If that filter is just a little too high or a little too low in the intermediate frequency stage of your transmitter, you're going to get a voice that is unintelligible because you are literally eliminating a great deal of the essential frequency information. For example, you might, if that response were up here in the intermediate frequencies, the low frequency components of your voice would be lost. If the filter were a little too low, like down here, just a kilohertz or so too low, you'd lose all of that high energy there, and you'd also let a little bit of the splatter through in either of those cases. You don't want to do that. So that's a very critical alignment issue in a transmitter. If you employ radio frequency speech clipping, you have to make sure that that filter is properly aligned in the intermediate frequency stages of your transmitter. Otherwise, you're going to have a bad situation. So there's a lot of stuff that you got to make sure you tweak and get just right. You don't want to overdo the clipping, as I said before. A lot of stuff you have to watch out for, including the background noise, which now you should hear in the form of the internal fan on this, the internal cooling fan on this Surface Pro 2 that I'm using to make this video. I'm using the internal mic. If I had been employing speech compression or clipping or any sort of method of improving the increasing the ratio of average to peak power, you might have a lot of trouble even hearing my voice over the roar of that amplified fan noise. But hopefully, well, that'll serve maybe as a little demonstration of what would happen. That fan would be so much louder that you'd have trouble hearing me through it if you overdid this kind of thing. Hope you get a little more understanding now about that process, especially if you're a ham radio operator. My call sign, by the way, is W1GV, Whiskey 1 Golf Victor. You'll find me on CW and PSK, primarily on 14, 18, 21, 24, and 28 megahertz. Until next time, 73, which means best regards, and so long.